Hello everyone. Today we would like to explain the exercise of Landau Lifshitz, in particular by assuming the such kind of function, so we can estimate the period of bounded solution. So to solve this equation, first we need to assume the total energy. So total energy is sum of kinetic energy and the potential energy. So by solving this equation, so we can write this equation with differential equation for dx dt, and by solving this equation, finally we can get the solution of t. So as a function of x. So this is the kind of potential shape, and we assume the bounded solution. So it means that we assume that this shape with some given energy. At that time, so we can estimate the point at the x1 and x2. So today, so we give two types two types potential. So first potential is u equal ax squared, and the second potential is u equal u0 tangent square x. So, but as you can see, so this function is symmetry. So it means that ux0 equal u minus x0. Then we can use the same x0 for this function. And yeah, this function is also same. So ux0 equal u minus x0. So in this case, we can estimate the period from 0 to x0, and we multiply the two factors. Then we can estimate the total period. To solve this equation, so we need to estimate the x0 value based on this function. X0 value is h of this potential by assuming the sum e. At that time, so this velocity is 0. So we can use this condition. So u equal ux0. So by solving this equation, so we can estimate x0 equal root e divided by a. So in the case of this equation, so we can also use the similar method. Then x0 equal arctangent root e divided by u0. Okay, so by assuming this equation, so let's try to solve the question 1. So in question 1, so we can insert this value to here, and also we multiply the factor of 2 because of symmetry. So then we insert ux this equation to here. Then we can get this integral. To solve this integral, so we need to exchange the value based on the reasonable function. So now we assume x equal root e divided by a sine theta. So this is a differential equation. So by inserting this factor, so we can estimate the t. So as you can see, so we can simplify this equation, and finally we can get this equation. So by solving this equation, you can get this solution. So this is the solution of potential 1. In the case of potential 2, so we can also use the same method. So we insert the x0 here, and we can also insert the u0 tangent square x. So to simplify this equation, so we separate tangent square x to x square and cosine square, and by multiplying the cosine x, then we can get this equation. So you know, to exchange from cosine square x to the sine square x, we can use this formula. So we can stack this equation like this. We need a root. Okay. So at that time, so by inserting this function into this equation, so we can calculate the t and the dt. So but when we calculate the dt, so you can find the cosine x dx factor. So cosine x dx factor is same as this factor. So we can directly insert this factor to this integral. So and at the same time, we also estimate the t0. At that time, so we can insert this factor x this factor times x sine x0. But x0 is arctangent root e divided by u. So it means that we can use this formula. Sine arctangent x is like this. So by inserting this factor, so we can get 1. So yeah, by inserting this factor into this equation, so we can solve this equation, and finally we can get this integral. So solution of this integral is sine minus 1, and we insert 1 to here. Then we can get this solution. So this is a method to solve the estimate the period based on the given potential and the energy. So thank you for watching this movie.